Hello, everybody. You hear me well? Welcome to the Microsoft Reactor. Isn't this a great setting? I wish we could have this event available to us every meeting. Let me put this on mute. Well, we have a great meeting today. We have two great speakers. Before we get started, there are some snacks available for you guys at the Microsoft fridge that are there. We expect pizza to arrive anytime soon, so hopefully we can do that at the break in between the presentations. Thank you for those who put their time and volunteering for putting this together, especially for Joanne Ryan, Anthony Cortez, Hannah Blanchini, Claire Hamilton, Kathy Sally, Josh Silverman. Please, an applause to them if we can. And obviously Microsoft for providing this stage and the food and the sponsorship. Hopefully it's not the last time we're here. Couple of announcements before I get started. Sign up for our announcements. We have officially changed name again. We are now become a nonprofit, and what that's going to help us do is two things. It's going to enable us to have a official legal form that would enable us to deliver better and more structured presenters. And the second thing, it will enable us to start receiving funds or collecting funds to bring more quality of speakers, offer more quality type of workshops, and apply for grants, and maybe bring people from outside the region. And so the only thing you need to do is support us by coming here, because the more we can prove that this is reaching a larger audience, then there's a reason for this organization to exist. So thank you for your support. We're turning 4 years next month, so it's amazing. So sign up for the monthly announcement on our website. There is a broadcast live online. All attendees are on mute. This is going to get recorded and posted in our YouTube channel. We have two speakers today. Alberto Tono, he's one of the members of the newly created foundation, and Daniela Escudero with Microsoft. All right. We have been selected for 2 events at Autodesk University this year. So we'll be hosting a panel that's going to discuss the nonprofit for learning communities. And then another event where we're going to discuss how to put together hackathons and the value of providing this type of events across the AEC industry. Support us if you're going to be at Autodesk University, attend the events, subscribe. We have yet to decide what is the lineup of the speakers, but we'll be attending that event. We love to follow hackathons, and a couple of weeks ago, the Build, now called DBEI, hosted a hackathon. On the screen, you see the results of the 3 winners who have made their code available. They are great presentations and great research efforts to support the development of the AC industry. The winner was Lian Nira, who developed a tool to enable cloud-based clashing for Hyper technology. There's more information about that on the link provided. The second place went to John Pearson, and the third place to Hyper. So check those websites. Code is free, and support the DBEI organization as well. There's a coming hackathon. Oh, there was a hackathon hosted last week in Toronto. This was the Autodesk University Generative Design, and the winner was this project called the Suret extension, and it was by Simon Breslav, Justina Sikowska, and Mercedes Karicki. Thanks, Mercedes, for providing the code. I already talked about our change of status, and one new thing in our website is that we now have a section called Hackathons. So for those who are listening this webinar, if you want us to promote your event or your hackathon online, just send us a note. We will be happy to include as well. Speaking of hackathons, there's one coming up, the AEC Hackathon hosted by Thornton Tomasetti. If you register and apply the code SFCDUG, you can get a discount. This is one of the most important events in the industry. And here's a very quick outlook of the type of events and talks they're going to present. More details on the link provided. A couple of new tools that we've seen on the market. This is a deep learning based tool that allow you to autocomplete phrases and paragraphs, similar to the type of things you see on emails or in Google. But it's a free tool that you can download the API. And the other one is Speckle. Have you heard about Speckle? It's a tool that allows you to connect data streams between Revit and Rhino. And this is now available as a Unity plugin. So it's open source, and the tool is available there. Thanks you for Christopher Morse, who worked on that. Next meeting, we turn 4 years, and it's a special event. It means a lot to me because I didn't know we were going to have this type of impact in the community. So thanks for your support. We're going to attempt to do a block party. We are still working with the announcements, so it's going to come pretty soon. Thank you very much, Microsoft and Tactic Studio, for the food and the place. And we're always looking for volunteer. This organization is nothing without your involvement with us. So if you want to be part of the committee, send us an email. Information is on the screen. Also follow us on Twitter. And again, thank you, HOK, Gensler, for the broadcasting system, and the AISF, who unconditionally support our events in their website. So with that said, I want to introduce the first speaker. Alberto's been working with me for a long time. He's been involved with the group a lot. He's going to show what he's been working lately in the realm of quality control. So welcome, Alberto.
Thanks. Does this one work? Thanks. Thanks a lot. Okay. Can you hear me well? Okay. So first of all, I would like to thanks again Microsoft and Tactic AR. If you haven't seen it, there are a couple of bottles of wine that you can experience also with whiskey and Jack Daniels without drinking, classic and illusion with augmented reality. So we're going to showcase that as well. We're going to have a real-time HoloLens 2 demo and also a tour of the facility later. So stay tuned, stay with us. The food is coming. So who is here that knew before the Dynamo user group, computational design user group, just to have an understanding? How many people? I think we have a lot of new people coming from Microsoft for see the demo as well. So just to have an understanding for the presentation. So this presentation will be divided in two parts, as you're gonna see. The first part, as we talk about, is how we want to have an impact in our community, talking about artificial intelligence, new technologies, especially for the AEC. That stands for architecture, engineering, construction industry. We're gonna see why we are supporting hackathons and events, why we want to establish a non-profit with this AI mission, and why it's important to collect data and provide visualization for architects about that. And the second part would be the part related to Microsoft technologies. We want to showcase the use of PowerApps and PowerBi with a new feature of PowerApps is called AI Builder. And we're gonna see a really quick example of deep learning with Keras for a time series forecasting. Was a pretty simple linear regression, but it's good for people who are not in the field, also like me, to put their hand dirty and see how it works. So finally, we are incorporated. This what we received this month was a really nice letter from the Secretary of State that we are doing business with them. So we are trying to reach the 501c3 status for tax exempt. That's a big achievement. We just provide the bylaws, and these are the most update topics that we want to provide as a service to the community to be more engaged with that. So we have a new button in the website just for you. Let's see if I can pull it up. And Su Young helped a lot to put it out. It's there. And we have different tiers on this. You can see where you can support in all many different ways, like food occasion, food for one, general donation, domain for years, membership, email, website for a year, non-profit expenses, and food for all. These are the main topic. We are gonna apply for grants as well, as we mentioned, like government grant or also other, specifically for the AC. These are the two main channels of energy we are doing right now. We want to sponsor open source initiative like PyRevit, Ladybug, Honeybee, and also Speckle, as we mentioned. And we want to aggregate all the work that has been done in all these hackathons that you have seen in a unique source of truth. So everyone can have a unique place to look for the work that has been done before. These are the two main topics. Why we want to do this? As you can see, this is the technology growth show from McKinsey chart. And as you can see, construction is not going up at all. The technology innovation that's happening in our industry is going down. And that's a fact, has a huge impact for all these different things that can be climate change, total energy, material, water. So all these are the impact of our industry doing the world. So in my personal opinion, and I think all the people here that are with you, with us today, has this kind of common mission to achieve and improve the technology to help the planet. And just because it's July and it was last week, the 50th anniversary of the Apollo moon landing, we want to bring us the most important thing of that mission. We went to the moon to discover the planet Earth. What would be nice in the future is that we don't need to go to the moon to discover planet Earth because we are living here. And we should take care in every second of our life about that. But what is important is actually what was the engine that bring us there. We feel that this then as a symbol of insatiable curiosity of all mankind. So this curiosity should bring us to share data in our industry, as we are doing with our lives, with Facebook, with Google. We are sharing data. Why we are not doing with our work as well? And so that's why we think a non-profit can actually serve the community to doing this, instead of be a corporate environment, a cooperation, or that's something that can come from us, from our community. So try to instill the culture of sharing data in our industry. So I don't know if it can be interesting for you. I want to share this video because for the anniversary. It was kind of super fun to me to see it the first time. Was a special call.
Searching for music for your next video?
Sorry for that, Mark.
Then you.
Yeah. A call that has been done from the White House to the moon. So just to remember that.
Hello, Neil and Buzz. I'm talking to you by telephone from the Oval Room at the White House. And this certainly has to be the most historic telephone call ever made from the White House. I just can't tell you how proud we all are of what you have done. For every American, this has to be the proudest day of our lives. And for people all over the world, I am sure that they too join with Americans in recognizing what an immense feat this is. because of what you...
It's kind of insane that we never done another call in the last 50 years like that to the moon. So we have internet, we are really connected to each other, but not to the moon. It was a kind of surprise for me to see that this kind of call can happen in the world. After saying that, because we are also really caring about this project, with our community, we started participate to Hackathon and provide support with an open source project started by HOK. It's called Mission Control, the project. And specifically, I want to say thank you to all the developers that help in this project. There is Danny here as well, and Dennis, and all the developers also from HOK, like Conrad, Danny Siroki as well, that keep helping the tool to develop. Also from Autodesk, a lot of people from Forge. This is the product that won a couple of hackathons, the AC one and the TT Core one, and specifically goes Project Eagle. As you may know, with this Design Automation API and Forge, you can access the model without opening. So you can land all your Dynamo script or your code on the model without accessing. So again, why we want to do these things? Not because they're easy, but because they're hard. And that's why we need to cooperate all together. As a mission control, what it is a dashboard, like literally mission control, the place where you can see all the model performance of all your Revit model or your BIM model in a web dashboard, accessible everywhere. So these are kind of parameters we have that we collect from all the models, our families, our views, the model size, the family size as well, the work set, and so on and so forth. So why we are doing this? This is the main question that we need to ask every time we try to do something. And we want to move all the efforts that have been done in our industry for 3D modeling, like augmented reality, virtual reality. And all this effort ended up right now, at least for my point of view, in PDF. That is kind of the black hole of all the information, all our efforts. So we're not going anywhere right now. We need to provide a constant maintenance of the model. So theoretically, the model performance should be like the dash curve. Right now, what we're experiencing is after every deadline, like SD, DD, CD, and so on, we have to clean up the model, do an audit, and so we can compact it and reduce the file size. It would be ideal to have a constant cleanup and maintenance of the file, so we can see at the end of the graph, we can have a file size that is lighter, faster, and we don't have trouble working on that model, basically. So how Microsoft technology can help us? Of course, Mission Control can provide a dashboard, but there are a lot of activities that can be done also with Microsoft product, like Power BI. You're going to see a lot of presentation about the integration with Power BI, with SQL servers. And right now, you can also connect Speckle with Power BI. So all the information that you have in your Revit model, you can send through Dynamo, through Revit, Speckle server, and then retrieve again in Power BI. So this is the first kind of workflow. You can have people working Grasshopper and Rhino, Revit, Dynamo, and also integrate the information between each other and send some of the information you want to display to the client in a web interface, or also want to have internally in your organization to see. You can display with Power BI. There is a query editor in the case you want to modify the JSON file from this. Like if you're using Mission Control, you will see we're using MongoDB as main SQL server. So you can retrieve a JSON file with that. What is more interested is to have this Power BI dashboard integrated in PowerApps. So you can provide to the user the ability to select which kind of operation you want to do. Like you want to clean up the views on sheet, you want to purge unused, and so on and so forth on the Revit model. So Forge and Design Automation can help in this. This is a typical workflow, as we mentioned, and I left like a small link there where you can access the Hestia file and you can start playing as well with the JSON format. This, what we want to show is different steps in which you can create classification on the model to understand if it's doing well or not, like good or bad classification, like The normal one you can see with cat and dogs. As you can compare cat and dog, it's going to be easier to compare good and bad model if you have a series of hyperparameters in your AI. So right now, who was aware of AI Builder and test it out? PowerApps allow you to have AI Builder. You just place the Excel file and they will find the best AI solution for classification for you. So it's pretty easy, user-friendly. Everyone without a technical background of AI can do it. So that's a simple classification we can achieve with AI Builder. And I'm going to show a little quick. This is another application if you want to do and dive a little bit more. It was done with Grasshopper. It's a plugin. It's called Owl. You can perform, let me see if I can show this video. Well, you can provide the JSON file or simply a time series, like in finance. It's a series of data point in time. And you can divide it into two parts, the train set and the test set, that you can train your AI agent. So the neural network is super easy to compose. You can see it's a couple of nodes where you define your sigmoid function, your alpha of the sigmoid function, if you're familiar with the terminology of AI. You can define also the number of hidden layers you want to have your neural network. And then changing the epochs, the number of iterations, as you can see, you're going to have the training part that is going to go closer to the validation part. I can try to show you again if you missed this part. Just simply change the number of epochs, so you will see it's going to go closer to the final solution. And modify the number of iterations. Let's try to reach the same level of that. See how it changes. So it's kind of a training that you have to go on. It's an easy way to explain to you how the tensor in a graphical way, because even if the other explanation that for who is interested, why we are here, because we want to share this kind of information with all of you, is the integration with the AI part with Keras that I mentioned you before. What we want to achieve is this simple threshold. So if the model is growing that fast that we cannot control, we want to be able to access to the threshold and limited amount. So in this case, when you are close to a deadline, the model the file size of the model increases a lot exponentially in 2 days, because people are throwing families, they are adding a lot of views and so on. So this kind of threshold that is measured on the angle of the linear regression between the data points, it gives you the dangerous, the likelihood, we can call likelihood of correction of the model. And so how we can retrieve that kind of angle automatically without looking at the data? How can the machine can understand this for us and perform all the action for us? So I apologize, I wanted to go direct to the OneNote and the Jupyter Notebook. If you want to have access to the code, feel free to ask me. I'm gonna share this with you. This is Keras. So you can see I changed the number of epochs here. I play a little bit with 10 and 0 just to show how the slope of the curve is going to change based on number of iteration. This is a simple linear regression. And if you want, I'm going through the code and what does it mean to prepare data also for AI training without using AI Builder. Basically, all the work you need to do. And let me go a little bit, start with. As you can see here is the JSON file, okay? At the beginning, you will see won't be formatted as we want. So you will need to use regular expression to clean a little bit the JSON file and having a format that can be in a tabular data way. So as you're gonna see, this is the way you can clean with regular expression. As you can see here, your JSON. And then after that, I'm gonna show, it's gonna appear in a tabular data. You can, you have different library you can import, like matplots. There is scikit-learn. In this case, I've used also Keras to work with tensor. And this is the point you need to arrive with. So as you have seen, it's a tabular data way that you can display this result in a tabular way. You need to work a lot with the data preparation on the first part to serve the data to the AI in a perfect way. So this kind of work require, I would say, 1 day or 2 for data preparation. Then you need to train your neural network to perform that kind of prediction. There are really expensive statistics software available in the case you want to do it. In this case, we perform with only 2 parameters, the number of views on sheet and the timestamp, basically. But you can, as you can see, you can do multivariant if you want to perform with the number of views on sheet. Like in this case, there are all different parameters. So when it's only about 2 parameters, it's easy. But when you have to have a lot of hyperparameters, like schedule on sheet, when it was create the views, the file size, and so on, you will need to perform a multi-variable environment. So this is how it has been trained. You need to import the Keras library. Is a library that is basically the main framework also for TensorFlow. If you are familiar with TensorFlow, it was a deep learning library developed for Google, and so on. So that's cut out. So if you're interested in that code, feel free to reach out to me. I would love to share it with you, and we can also start a conversation with that. And I would like to try to engage for the next step. We want to be able also to visualize the model directly in the web. So there are a couple of frameworks, like Forge Viewer is free, and also Torto Mazzetti offer a free, it's called Spectacles, free viewer for model. So I strongly recommend to use this kind of framework to help. So this will be I'm gonna pass the ball to the next speaker, Daniel. He's talking about how you can bring this 3D model that are accurate, done with this AI, to an augmented reality environment. So thanks a lot for our sponsor, and thanks for listening to me. Yeah. I think we can do the break for the pizza, if it's arrived.
Hi, welcome to the Microsoft Reactor. I'm Jo Ryle, Head of Marketing. How many of you have been here before? Recognize you, actually. Great, and welcome to all you new people, and welcome back to all the people that have been here before. I apologize, we did order pizza to arrive at 6 o'clock. We're let down by a company that I will not name. We have now gone with another company. It should be arriving at 7:20 to 7:30. Normally we block off the area of the snacks and drinks. If you're hungry, I know you come from work, eat whatever you want, grab whatever you want, okay? It's fine. It's not a problem. So between like 7:20, I think we expect the pizza to arrive. And then we've got somebody coming at 7:30, but who's going to be doing the Capture Studio tours. He'll start them at 8 p.m. to 9 p.m. It's during the networking period, and it's actually back through the FDE space in the green room. And we're really lucky to have him do these demos for you guys. It'll probably need to be like 20 people, maybe maximum 30 people at a time. We can line you all up. And then Dan, are you planning to do a demo? Demo of HoloLens 2 on stage from Dan. And Dan Escudero is our head of technical design at the SF Reactor. We're part of the developer ecosystem team. And he's amazing, very knowledgeable, and I know you'll love his presentation. So thank you very much for coming, and I apologize for the lateness of the pizza.
Hello. Seem to work? Yeah, okay. Hi everyone, my name is Dan Escudero. I am the Mixed Reality Academy design lead, as Joe said. I'm a designer, right? I started getting into programming like over 15 years ago. Started with Flash design and then development. Then moved into Unity because Flash died. And I've been 3 years now at Microsoft working for the HoloLens team. Started out doing prototypes for HoloLens apps for some of our like big customers in Europe, like Airbus and other big names. And now I'm more dedicated to actually like teaching developers and showing what we have, where we're going, and also participating in the mixed reality toolkit development. So I'm currently working on some experimentation around hand menus for HoloLens. So yeah, I'm really fortunate, I guess, to be here. So in February, we announced HoloLens 2, right? Showing the amazing capabilities and improvements that we've made to this device. And how many of you here are designers? Developers? Designers/developers? Okay. You got to bridge that gap. Designers have to become developers now. You can't just be a designer. But anyway, what we want you to do is actually get started developing for HoloLens so you're ready when it launches. Okay, so that's what this talk is about. So let me show you this video first. Let's take a quick look at the main capabilities that this device has that is going to change the way how we interact with computers from now on. Okay, so let's get started with the first one. Sorry, and we call these instinctual interactions, by the way. So we're going to go into a bit what that means. So now we're telling users to reach out and touch holograms. Just literally stretch your hand out and touch them. And touch is one of them. You can do things with voice, you can do things with your eyes too. So how do we achieve this? So the HoloLens 2 has fully articulated hand tracking. So we're tracking 25 joints per hand, which allows us to do some pretty magical stuff. So we know where your hands are, not just in respect of yourself, but in world location. We can track simultaneously. We know which hand is which, of course. We can show you the hand mesh, and you can see it displayed on your hand. As a developer, you can choose if you want that or not. And the latency is super low, so it's pretty good. The next one is eye tracking. Now, the eye is the fastest muscle in the human body. So it's basically, you need zero effort to move your eyes and do something with your eyes. And it's a great alternative input. So if you combine it with hands or voice, you sort of like merge something magical together, and you'll see why in a few minutes. We can also mind read a user, mind read in a fake way, because we know what a user is trying to target with their eyes, so we can kind of infer what they want to do. We can also track a user's attention. So I'm going to show you later a bit of a heat map of where people are looking at. And of course, Windows Hello uses iris recognition. So when I put this device on, it knows it's me. It says, "Hi, Dan." It logs me in, signs me into my account. I don't have to do a thing. And it adjusts my IPD so that holograms are rendered in the exact place where they should be, just for me. The third one that makes all of this magic happen is speech. Now, how many of you here have actually worn a HoloLens or used it? Even like the old one? Awesome, that's good. So one of the problems that we found with HoloLens 1 is that sometimes you can hear, or it couldn't hear you for a voice command. Sometimes someone else could trigger a voice command on your device. So we've improved the microphone array. It's now pointing straight at me. So when I speak, even in a very, very loud environment, it understands what I'm saying. So speech recognition is much, much better, and noise suppression is very aggressive now. So you could turn on a blender right here and still do the speech commands, and it will still work. And also, collaborative sessions between HoloLens users is quite a common thing. So triggering someone else's voice commands was also very common, and now that's not going to happen anymore. So as you can see, designing for HoloLens 2 is very unique. It's nothing like designing for any other device. Just like in the real world, we touch things, we grab them, we reach out to them, and the HoloLens understands. We use our eyes to look, to focus, to read, and HoloLens understands. And we use our voice to quickly get to where we want to go, and HoloLens understands. So designing for HoloLens 2 means endless possibilities of interaction. So how do you decide what is best for your end user? Like, what is going to help them achieve that task that you want to help them with? So to make complete solutions as straightforward as possible, we are creating 3 end-to-end interaction models. First one is hands and controllers, second one is hands-free, and the third one is a classic gaze and commit. And we've seen that different customers need different solutions. So all these interaction models are scenario-based. They're based on real-life scenarios. So let me dive into them quickly so you can get a better picture of what they are. Hands and controllers. The model covers intuitive, robust interaction for scenarios where you require rich interaction with holograms. So like literally touching, pressing buttons, swiping, grabbing something, inspecting it. There's lots of like physical movement in there. Or controllers, doesn't have to be hands necessarily. The second one is hands-free. So think of like heads-up display, where my hands are busy, probably with a tool or 2 tools, and I'm inspecting something, so I have no use of hands. So it's more about eyes and voice. And the third one is we call it classic, because it's useful for HoloLens 1 and HoloLens 2. It's based on gazing with your head or with your eyes and committing with an air tap or some sort of click or speech. So it's very good for accessible controllers. If you want to know more about these 3 models, please visit aka.ms/mrdesign. There's lots of recommendations of what to do and when to do it. But there are 2 capabilities that stand out the most, which I want to dive into. And the first one is hand tracking. Probably my favorite. So what I'm going to show you now is some of the learnings that we have applied to the mixed reality toolkit, which I'll explain later. It's a toolkit that allows you to quickly put together your applications. And these recommendations are already built into the toolkit, but I want you to understand why we've made those decisions. So hand tracking. Despite we are tracking all joints and all the tips of our fingers, we recommend using one single point of interaction. And the problem and why is that because since there is no haptic feedback on a hologram, you reach out to it, you can trigger it with all fingers. So you want people to focus on the main one. So if I have imagine a digital piano, which I'll show you later, by the way. If I used all my fingers, I would trigger them like all the time. So you have lots of like false positives. So we are asking people to use just their index finger. And that allows for simple taps or press, another sort of like tap, or if the button is bigger, more of a like hand press. And those are like the three main ways that people interact with holograms, like that, that, and that. Depends on the hologram, the situation, but those are the three main ones. So that will reduce, focusing on one contact point will reduce lots of errors. Again, since there is no haptic feedback, we need to provide visual and audio cues. So in this example, we have a nice sphere in front of me. We are applying the bounding box, which is it's a nice tool that we recommend using. And as my hand approaches this sphere, imagine I had a flashlight on the tip of my finger, and as I approach the hologram, that flashlight should affect the hologram, showing me how far or how close I am from the hologram. So as I get closer, the sphere, the like illuminated sphere, will start to reduce until I eventually touch it. At that point, you trigger a change of color, there's a ping or a bong, whatever you want, and then you release and you have the reverse effect. But those audio cues are fundamental. Otherwise, people do get lost. They're not very, their eyes or our eyes are not very accurate at distinguishing the real distances between light, because you're basically looking at light. It's not like a real object. So we apply these rules to all our buttons, and buttons, we mean the start menu. So when I trigger the start menu, it opens up. I can see my finger affecting the buttons before I touch them, and I know how far they are or how much I'm going to have to press them. Keyboard, same thing. The keyboard is actually super satisfying to press, and I'll show you later. And of course, you have buttons on holograms that you should still apply the same rules. Now, what happens when you have a 2D slate? You can still have 2D in a 3D world, right? So imagine you are looking at a PDF or a PDF reader, and you have that on a 2D slate. The way you interact with it is simply like swiping up or down. Maybe it's this way or just the whole hand, but people assume that, and that's what it does. If you see a link, you press it, and it links, and it clicks. You can also do zooms in, zooms out, all that stuff. So it's very instinctual. A little tip about holograms. Like, this is not a very known thing, but the size of holograms determines how people interact with it. If it's a small hologram, like this could be a small hologram, if I reach out and try and grab it to move it to another place, I'll be very delicate. I'll probably do this, just grab it and move it around. If it's a bigger object, I will probably do a grasp. I will move it around. And if it's even like a bigger object, I'll grab it with two hands. So the size will affect how people interact with them. So keep that in mind. But the good thing is that the toolkit has all those tools for you to play with, and all those options still work at the same time. So bounding boxes, we saw bounding boxes before. And bounding boxes are this like universal way of wrapping a hologram. You could have a hologram which is a sphere, it could be a snake, it could be any shape and size, but you want users and people to understand that there's a language behind the manipulation of an object, of a hologram. So the bounding box is a nice universal way of saying, okay, there's a space around it. This is how you scale something, or this is how you rotate. So as your hand gets closer, you might see the bounding box appear, and you see these little affordances on the corners or on the edges, and those allow you to either rotate on one axis, scale up or down, or even grab two and scale up or down. Or actually, if you reach into the hologram, just grab it and just move it around. But that way, everyone understands how to interact with a certain hologram that is not a button. So we've been talking a lot about near manipulation or near interaction. So what happens if you have a hologram that's far away, or you want to push one away? We then resort to far manipulation. And what that means is basically, just like in VR, you have hand rays shooting out of your controllers. You have hand rays shooting out of your hands. So it's like Spider-Man powers. You literally lift up your hand, you get a ray, target, grab, move around, use both hands. I'll show you later. Very, very intuitive. So let's take a look now at eye tracking, the other one. super interesting what you can do with eye tracking, but it's a tricky one. There are some pitfalls, but I'm not going to go into the pitfalls. I'll go into the how you can actually use it. So the Mixed Reality Toolkit has some great examples of good uses for eye tracking, or proven uses of eye tracking. So let's take a look at some videos that will show you what's going on. So here, there are some holograms right in front of me, right in front of Sophie, actually. This is not my video, it's a colleague. And Sophie is looking at the gems, and she's saying either select or pop. And she makes them pop just by looking at them, or by looking at them and triggering with a tap. Super fast. There's actually a very faint cursor that you can see, and she put that deliberately so people could see where she was looking at. So again, looking at something, saying pop or select, and it's done. Very, very easy and intuitive. The next one is eye-supported scroll, pan, and zoom. So think of like Google Maps, and you look into the map, and you can zoom in and zoom out exactly where you're looking at. So you determine what your focus is. And that's super magical. You just like play with it. Or you can actually scroll it. So you look to a side of a map and it will automatically, slowly, gradually scroll. Or you can look at an object and it will rotate. Or you can look at an object and select it. Very simple. Another good example, this is my favorite. This is a bit more tricky. So what she's doing here is she's looking at something, she's selecting it with her hand and moving it around. But the target is determined by her eye gaze. So she looks at it and literally says, put this there. So here's another example. Right now she's going to start saying, you can barely hear it, but I'll fill in the gaps. She says, put this there. 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 So no hands at all. That's pretty amazing. Did you ever think that you could control stuff with basically with your mind? You're saying it out loud, but it's pure magic. Another example, visualizing visual attention. So think of a heat map of where someone is looking at. This is a small demo app that Sophie made where she was recording someone's eye gaze, and she created a heat map. And now she's rerunning that, looking at it from a third-person perspective. So you can see where that person was looking, the whole flow of that person. Pretty incredible. Imagine if you apply that to retail or advertising or like education. So how do you get started? With Unity, for now, with Unity and the Mixed Reality Toolkit. How many of you use Unity? Just a few. How many of you know what Unity is? Okay, so yeah, I assume like most of you know what Unity is. Okay, so the Mixed Reality Toolkit comes in the form of a Unity project. And it's a ton of very, very useful tools for rapid mixed reality development. These are most of the tools. Let's name a few, like the input system, of course, so you can do all your inputs in different form factors. Transforming objects into an interactable object, bounding box, object collection, spatial understanding, attached to controller, the Mixed Reality Toolkit shader, and of course, hand tracking and eye tracking APIs. So the best part is that the Mixed Reality Toolkit, each tool comes with an example scene. So you can literally run them inside Unity in the editor. You can deploy them onto HoloLens 2, HoloLens 1, or in your Windows Mixed Reality headsets. And you can, of course, rip them out because it's open source, rip them out and put them in your apps. So instead of boring you, showing you like each individual one on a slide, I'm going to do a demo. And I'll show you a few example scenes so you can see what I'm talking about. Wow, that worked fast. Let's hope this connects. Okay, awesome. Okay, I'm going to turn the volume down. There's a certain lag here between what I see and what you see. It's just a couple seconds. Okay. So since there are some designers here, I want to go into some nitty-gritty stuff that I love showing. So for example, if I lift my hand up and it hasn't scanned me, it will do the hand tracking mesh. It will show me the mesh. Now, what you see on screen isn't exactly what I see here. And the difference is that when I see this and I see the hand mesh, it really fits my hand right where it should be. But here you might see some displacement, but that's normal. Don't worry, that's just the stream from the device onto the stream. It's not what I see. Okay, so what I have here is the mixed reality toolkit scene. I'm gonna approach this hologram. This is a nice like entry port into the hologram. I'll press play, and I'll get put into this immersive app, which takes over, think of like a full screen app. Okay, so I have a bunch of little scenes here, and all these scenes exist in the Mixed Reality Toolkit project. So let's start with the basic one, or the most complete one, I would say. So I'm going to go into hand interaction examples. Okay, and I have a bunch of different holograms here. So we talked about lots of these. Let's start with the basics. So let's start with buttons. So these buttons, you can see my hand here. And as I get closer to them, you see how the button reacts. There are a few effects. One is like a rollover effect, and on the other side, you see this little effects that tell you how much you have pressed. So you don't have to go like straight through me. You know how much you have to do. You can actually, yeah, the sound is still there. Thank you. So again, it's still tracking my other fingers, right? Oh, it's not. Let me see. It was. No, it's not. Okay, that's good. It should track only my index fingers. Okay, so let's talk about other controls. So we talked about the bounding box. The bounding box can be set by default. So at start, it's already there, like this one. Or it can be activated by proximity. So as I get closer to this piece of cheese, I see it. See how my hand affects, and you can actually see my finger getting close to an affordance. And when it goes blue, I can grab it, or actually just grab it. So let me do it this way. Sorry, I don't want to give my back to other people. So let's put it back where it was, down here. Again, activated by proximity. I can take a sip, or I can just go and grab it, still attached to the other hand, or rotate. Oh, let me see. There we go. On one axis. Here I have a super boring 2D slate. But the important thing is I can scroll up or down. Or I can tell it to annoy me and follow me around. So if I have instructions and I'm walking around a piece of machinery, this thing will actually continue with me, unless it touches something else. But let me put it back. What else? A few things. So we talked about the hand mesh. So this is the default hand mesh, but you can see some weird cubes right in the middle. So I'm going to turn off the hand mesh. And now you can actually see, it might not align perfectly, but I can see it really well aligned. But these are the joints. Or I can turn the joints off and they're gone. And I'm still interacting with stuff. I love the hand mesh, so I'll leave that on. Sliders, changing the color values in this little gem here. Or as I get close to this, I don't press it, it just reacts to my touch. So for example, let me inspect something. I can grab this, take a look at it, make it bigger. Actually, I'm gonna use a combination of stuff here. So I'll grab it. I'm using it at the far ray now. So I'm far enough to actually activate automatically the hand ray. So I can grab it, push it around, push it even further if I can get out of the way. There we go. I can literally push it out. Or I can do this, grab it with two hands, just play with it as if it was close to me. Or bring it back, I'll try and bring it back. There we go, and grab it again. You can launch Edge inside your app. You can navigate stuff. You can launch settings and other really important things. And of course, you have like gravity, all the physics that are integrated into Unity. And of course, you have Unity UI that also works by default. So let's take a look at a different scene. This one is the MRTK shader. So like me, designers normally don't like shaders. Like nobody loves shaders at all. It's so nasty to work with, right? So the Mixed Reality Toolkit shader was specially developed by Microsoft to perform really, really well on mobile devices, including HoloLens 1 and HoloLens 2. So all these effects that you see here are on one shader. And it includes like iridescence, inner glow, near clip fading, ghost effects. There's this stencil test, which is awesome. Everything is in one shader, and it runs at 60 frames per second on this device and on the old device. So if you want to use a shader, please use this one. So let me show you a cool effect. So this is a nice simple effect that comes built in. So we have a nice heart. And if you want to look inside it, you would normally have to do some very weird things, like putting your head inside it and taking a peek, which is not very comfortable. But you can do something a lot cooler. So you grab this little sort of lens here, and you just clip into it. Or in fact, it's a bit small, so I'll just push it in and take a peek. Or you know what? Let me make this bigger. Oh, now I'll do it. And I can put it inside and explore all the valves, all the stuff that I have no idea what they are. Or even combine it with another one and put it in there. I'll make this one bigger. So imagine how you could apply this to like anatomy in general or other things, just to inspect. And these are just built in. They work out of the box. There's nothing special that you have to do on the shaders for these things to work. And let me show you the last one. Tooltip, very, very simple, but all these things are ready. They just work out of the box. So they are billboarded towards me. Their actual lines change depending on where things are. I can move things around, and as you can see, the tooltip is always facing me. And I think we have some other options here, but I haven't explored them. You can paint them. Yeah, you can do tons of different things, or show and focus only when you roll over, or show and press, etc., etc. So yeah, let me go back to the slides. Unfortunately, my slides are dead. Come on. Not showing up.
Oh, there we
So
go.
after Dan's presentation, if you have any questions, I'll be walking around with a microphone. If you can wait for me to get to you, I can hand you the mic so that we can capture it on video so that we can eventually publish it and more people can learn about the questions you have and the answers he can give at this point in time.
Thanks, Joe. Yeah, so to get your hands on the Mixed Reality Toolkit, just go to aka.ms/mrtk. It's an open source project. It's getting pretty robust. So take a look at it. You can play with it right away. The best thing, you can press play in your scenes and use a Windows Mixed Reality headset, which can be very cheap, and just play around. And those will also work on HoloLens too. So you can start prototyping right away if you want. So a ton of you will ask, okay, so when can I get my hands on one? We don't know yet. But it's coming, and there's a development edition. So if you want to be informed about it, especially about this edition, go to aka.ms/iwantmr and sign up for the developer program. You'll get tons of news from our team and from the HoloLens team in general about not only when it's available, but events and other important things for you and resources. And last thing, here at the Reactor, we have our own HoloLens and Mixed Reality meetup. We run it every month. Next one is on August the 12th, where Jesse McCulloch, one of our program managers, teammate, is going to do a hands-on create your first HoloLens 2 app on stage, which should be lots of fun. And we might have some like demos also. So thank you, and yeah, I'll open up for questions.
Okay, we've got the first one here.
Yes, I noticed from your demo that at least the hands, it recognizes the joints. Are you going to actually open the, because I noticed that you were trying to play with all your fingers on the piano. Are you guys going to actually have that available to kind of like, hey, instead of being my index finger, can I adjust it to my other fingers?
Yeah, absolutely. You currently have access to the 25 joints transforms, so you can do whatever you want. For example, the hand menu thing that I'm exploring actually attaches to the palm, and we have done other experiments around here because we know more or less where your wrist is. So yeah, you have access to everything hand related. It's not hidden at all. You're not given the fingertip. No, exactly. To repeat your comment, HoloLens 1 only gives you a few events, and those transforms related to those events. So finger up is one, air tap is another, but now it's open, where you have access to all of that stuff. Yeah.
Our team has been developing for the HoloLens 1 in a manufacturing setting for satellites. One great feature I saw was interacting with 2D landscapes like PDFs or web pages. You said you'd talk about the keyboard.
Yeah.
Or interacting with that keyboard. I was curious.
I didn't show the keyboard. Yeah. I forgot. Damn it. Yeah. The keyboard, you can bring up the keyboard whenever you need to. The keyboard is, for now, again, based on the same recommendations, it's index fingers. It's much faster than before. You can still attach a virtual, like a Bluetooth keyboard, but it's much faster. And it has dictation right there, so you can still use your voice instead of typing it. So it's pretty fast in general. We actually have submitted tons of bugs on the device itself, so you can imagine how much that work is, like typing like this. So we normally just literally dictate them. It's much faster. Yeah.
question for you. So what I see is a lot of controls and things like that, and being able to interact with controls. Does the HoloLens actually map out the world around it?
Yeah, absolutely.
Especially things like light sources. That's actually one of the things that I'm most curious on.
So it does track the world around you. It does build a mesh around you. There are a couple of versions of that mesh. There's a dirty mesh, a cleaner mesh, and a super clean mesh, closing holes. There's tons of work around there. So all the goodness from HoloLens 1 around spatial mapping is still in there, and it's the poly count of that mesh is even higher. So the resolution is like even smaller. So it's a much improved version of what HoloLens 1 could do. In terms of light source, we have an open source project from a colleague of mine, which is the mixed reality lighting tools. The lighting tools do light estimation. So they more or less understand where the brightest areas in your room are, and those affect the reflections on your holograms. So literally you put it on, you enable light estimation, and your holograms can actually reflect real world objects. Any other questions?
Yeah. What's the biggest number of polygons of a model that you tried and doesn't lag?
Okay, so for people who don't know, the HoloLens ideally, well, it has to run at 60 frames per second for it to be super smooth, stable, and to do things properly, right? Unfortunately, lots of developers forget that, or they just don't care. So one of the limitations or things you have to keep an eye on is poly count or draw calls. So that's a very hard question to answer. I have seen very optimized applications that have over 1 million polys. But most applications that have 1 million polys, they run at like 10 frames per second. So you can have a bit of both, but you need like a brilliant team behind it to reach that amount. Now, one of the services that we announced not too long ago was remote rendering. And remote rendering is basically Azure, the cloud, rendering objects as you move around them here. So if this is my hologram, I move around it here, it sends the information to the cloud renders, and it renders it back in my eye, and I assume this hologram is here. But it's rendered up there with like trillions of like infinite amount of polys. So that's the solution to the actual problem, because you can't make this bigger. I mean, you can, but battery life, like weights and all, like nobody would use it for more than 10 minutes. Yeah.
Hi. So I was wondering what you guys have done to, so I work on a team that's been testing Microsoft's HoloLens 1 in a like outdoor setting, and the holograms, of course, when they're outdoors and the sun's, you know, it's not in a controlled environment like this, then, you know, it's kind of hard to actually see the holograms. I was wondering if you guys had done anything to like improve the HoloLens 2 in that way. And also I kind of wanted to hear about the FOV, if you could just talk a little bit about that.
Yeah.
So I'll leave you to talk about FOV and also your comments on that. But obviously we're working with the military, so I anticipate that there may be something that will be outside. I can't comment. That's my own opinion. It's not Microsoft's opinion. But I will leave Dan to comment because there is quite, as you mentioned, there is an issue right now when you take the HoloLens outside into the, you know, sunset, you know, like it's not clear.
Yeah, so the issues with outside are due to a few things. There can be issues, and maybe there aren't any issues. Being outside doesn't mean that your app is not going to work. It's all about tracking and sunlight, and what you see, of course. Tracking, if there's enough feature points, no problem at all. If you've got direct sunlight on you, yeah, tracking might not work, and it's most probable that it won't work well. But also, you wouldn't see holograms either, because you're like throwing more light at something that's already like super bright, so you wouldn't see a thing, to be honest. So that's probably the biggest problem of exterior sunlight is the amount of light. More than tracking itself, it becomes like useless if you are in an extremely bright environment. That might change in the future. We don't know. But yeah, it's affected by a few things.
In our project, we struggled a lot with accurately overlaying models on physical objects.
Mm-hmm.
We try to do a lot of things to try to improve that, but I was wondering for HoloLens 2, has that improved? Because I think what we found was kind of relying on the internal accelerometers and all the sensors to accurately track your position. It's really just making an approximation, right? Has that improved for HoloLens 2 to where we can actually look at overlays that are, accurate to, our goal is really a centimeter or even less?
Right. I have tried on HoloLens 1 doing the same sort of thing, up to like trying to match a sneaker, holographic sneaker on top of the real sneaker. So I could customize it, which is kind of like the same thing. Yeah, and it's not the best. I wouldn't say that the tracking is wrong. Alignment is can be off. Now, one of the things that affects alignment is IPD. If your IPD is not set accurately, your hologram will be off. No matter what you do, it will always be off. If you like sway to the side, it might move in a different direction, so it will never be on top. So IPD, and especially now, automatic IPD, will sort of solve a big part of that issue. Then there's tracking itself. Now, tracking, again, depends on a few things like the feature points and all that. The new mesh, the spatial mapping mesh, is a lot more accurate, just because the depth camera has more resolution. So I haven't tried this myself, but it should be much more stable than HoloLens 1, based on those two assumptions. I know that we are constantly requested to do object recognition, 3D object recognition. So hopefully the rest of the team do something about it. Yeah.
Yeah. Again, talking about the topic of being outside, we developed applications for outside usage. And the main problem was not actually the light itself, because if you're smart enough, you can figure out a way to see the you know what I mean. The biggest problem actually was the heat sensor. Like it was shutting down after 5 minutes if you had direct sunlight, because probably the heat sensor was too much on the outside, and so it got the heat was going up very fast, and so the device was shutting down.
Right. Yeah, we have some funny stories about prototypes about that. Yeah, on HoloLens 1, I don't know like the official numbers or how much it can stand heat. That's a very good point, though. I do know that on HoloLens 1, everything was packed on the same side. Now everything is distributed in different parts, like especially back here. So I would assume it is better, but I wouldn't dare to like answer properly. Like this is the answer to that. But yeah, it will be different, definitely. Yeah.
Hi, I work in the construction industry and especially with building information modeling, BIM. So I was wondering how far along is HoloLens supporting the 3D models of a building? For example, imagine this room, it has a lot of ducts and lights. And his question was correct about if it can handle 1 million polygons. If it puts it to 10 FPS, is it ready for the construction industry, and how far along?
So yeah, to answer your question, you can run 1 million polys or decimate your model down to 10,000, but you need a team of people to do that. And that takes at least, like, if you want to do it on a car, say you have the AutoCAD model of the car, to decimate that and optimize it for mobile consumption, it takes a team of like 3 people a month, more or less. If you want to do it with a building, it's very similar, with different layers, of course. So that's why remote rendering exists. Because one, you can run countless polys on the device just by streaming it to the device without the user knowing it's coming from somewhere else. And also, you're avoiding that team of 3 people for a month. So the cost is nothing. So that's why this service exists. HoloLens 2 and Azure Remote Rendering are made to work together to solve that problem. So it's not a matter of the device, because no device will actually do that. It's realistic to do it. So that's why Azure does it for you in that sense. Yeah.
So one more question, and then I'm going to get on stage and do an impromptu presentation while the pizza arrives. Okay. I'm promised it will arrive very soon. So we'll let this lady talk, and then I'll get on stage, and then there will be opportunities to actually meet with Dan and talk one-on-one with him.
Yeah, but you can ask me questions
in
later.
addition to going backstage and seeing the green room and getting the mixed reality capture studio. And if you're not interested in listening to my presentation, that's totally fine. It's impromptu. It's just like, just giving you some background on the reactor and what we do here, especially if you've got meetup groups or you've got community events that you want to host. This space is free of charge. We don't charge you for it. We provide that excellent man back there, Anthony, who's our AV expert. He's always here for us. We provide excellent speakers like Dan and Nick, our lead engineer, and as well as we've got a V team with cloud advocates, Azure specialists. So if you, sorry.
The question. I want to answer the question. You can.
Yes, so I'm sorry. I'm going to let you talk. Ask the question. Sorry.
Sorry, Joe.
I work in the construction industry too.
Sorry, can you put it closer to your mouth?
I work in the construction industry too. So with a lot of headsets, people have the feedback that they cannot wear it for too long because they feel giddy or something. So I don't know if that's an issue of the FPS or the IPD, but are you working on solving that? So
on the weight? Sorry.
It might be a factor of the IPD, like understanding the focus of the objects of the hologram. I'm just saying that people are not comfortable wearing.
Oh, okay. You mean wearing not necessarily physically, but like eye strain?
Yeah. Okay. So are you working in that direction?
So yeah, IPD is fundamental for that. Some people might be a bit uncomfortable seeing light because it's literally light being projected into your eyes. So it can be bright. There are some design guidance on what to use and what colors to use just because of that, because most people assume that, yeah, I can do my make them white. You should never use white. You know, there are like certain suggestions. IPD makes a big difference though, because if they're not adjusted for you, it becomes very, very uncomfortable, especially if the previous person or whoever said it before on HoloLens 1 had a wider or narrower IPD. And that means that a hologram, you might actually see it double because it's like your eyes just can't do the work. And to answer your question over there about field of view, I forgot that one. Very important one. That also makes it a bit more comfortable because the field of view is now double the surface. That's why you can actually reach out and touch holograms. Before, you had to see them from far away so you could get the whole picture. Now you can literally just walk and touch them. So that's the basis of like instinctual interactions, having them really close and you can still see them here. And that allows people to just walk up and look at them like fairly closely and play with them without trying to figure out or seeing them from far away also means that your eyes have to calculate how far they are anyway. So there's like this constant battle of back and forth and real objects. But now holograms, in theory, or most of them are closer to you. So it's a lot more comfortable, apart from being physically way more comfortable. So you put it back on, it's much lighter. There's no like pressure. It's been like really, really improved compared to HoloLens 1. So yeah. That's it, Joe? No more Joe? Okay, thank you very much.
Dan, would you do me a favor? We can take 15 people into the back room for the mixed reality.